Okay, and just like this little note, it says, Control H is, find and replace, as opposed to just Control F being find, so you don't have to mess with it, it's just faster. Okay, this subject, it's called function pointer mystery, which really isn't a big deal, and I was really confused when I was writing this thing. So basically we have a function, which kind of pointlessly accepts a void pointer as input, but this guy just does this for reference. Um, and then we have a function 2, which accepts a function um, pointer as a reference. And this is how you would declare it if you wanted to pass a function pointer into another function. And then this just has a p void and a couple of integers, and you can see what it's doing here. It's passing integers in, and that that pointer to this other function, and like I said, this function 1 is never actually called in code, only function 2, and function 2 is called, passes its parameters to that function, which then executes, returns its code to here, which returns it back to the calling source in main. And here's just an alternate type def version of it, which that dummies book guy likes to frickin' use, but again, that kind of obfuscates what you're doing a little bit. So, personally, I don't like that form, particularly since it's only, again, used once. So, but so this does exactly the same damn thing as that above. This right here is me experimenting with it. Function 1 in this case not only accepts a pointer but also a reference. So the function 2 is what's called, and it's passing a function. You have to duplicate the form of it, in your input if you're going to call it. So again, you pass in a pointer to a function, and you'll see that down below. Then some parameters and some references, so it does that. Now we're getting into the code here. Okay, so right here we're calling pointer. This isn't in the book, so and I don't really do anything with this. I'm just declaring a pointer, my pointer. Because this is how you declare just a function pointer. It is a weird way of declaring a pointer, because this is the name of your pointer, but you have to dictate the form of that pointer, right in the declaration code. So it is a little weird, but still, I think it's clearer to do that than to not do it that way. So you're making a pointer function here. And here I'm just defining an integer, but I'm going my pointer equals and func, so I'm basically assigning the pointer the address of the function. So which I'm surprised you need to do that, actually. Yeah, you don't need to do that. You don't need to put an add or sub, and you don't, because a function, and this is what I didn't understand at the time, but a function, when you don't put the parentheses around it, is actually a pointer. So, you don't need the add or a sub operator. There's no reason to put it in there. You can just for shits and giggles, like I did have it, but I would need it if I had parentheses around it or something, but on the other hand, that would be an error, because it accepts arguments. So, that would give you an error if I had done that. So, you'd have to have the full form of it or whatever. So, but I mean, if you're wanting to assign a pointer that's existing to a function, that's how it is. But, the form of your pointer still needs to be the same form as the function. But if you had a lot of functions with the same form, you could theoretically point to any of them. This is just so it can keep track of the fact that it's going to see a return value, and it's going to take parameters as input. That's the only reason for it. But what the function does could be any number of functions. So if you had like 10 different functions that accepted these same parameters as input and then returned this same type, then this function could be, this pointer could point to any of them, and you could change it dynamically, which function it points to at any given instant. So and again, ignore most of my comments. It's just me being confused back then. And I'm going basically R value, which is our integer here, equals function 2, and then I'm passing in function 1 with these parameters, and it's going to return a value to it, and then I'm printing the value out, which it just adds 5 and 2 if I recall, for that first example, because these are lowercase functions, and then these are the ones that are defined using his weird template. Does the same thing, so it's going to return 20. Okay, then we got all this garbage going on down here, and because again, this is me getting confused with the fact that he is actually passing a pointer in. He is, and that's the proper type because he's just listing function by name. So you do that, that's a pointer. It's just always a pointer. I could do the same with func2. I could pass it in with no parentheses or anything. That's a pointer. So I could pass this into one of these other functions, but it's the wrong type. So anyway, but a function could be set up to do that anyway if you wanted to for some weird reason. So, but this is about passing functions, to values, and and that's rarely done. That's what Chili was saying. He talked a little bit about that. Said, you'd rarely ever want to do that in code in practice, but there's sometimes when you're working with like Windows that you need to pass it in functions. So, because it needs to do callbacks, especially with the COM objects, component object model, COM. Those need callback functions. So, that this is an example of a callback function, or or at least passing a function into another function, and having it return a value. So it's not an example of a callback, but it's an example of passing functions into another function. So that's what this code snippet was all about, and that I just got kind of confused with it and started experimenting with it. But this thing does not need to be passed p void. So don't think that's a requirement. I mean, because he could have just passed x and y, which is the only thing it needs to be passed. He's just demonstrating that you can pass a pointer, just a random pointer, into this function of type void, and then pass it on to that. But a void pointer, I don't know what the usefulness of that is. But down here, I'm experimenting with not passing it void pointers, because like, what's useless? Why the fuck would you want to do that? So I pass in not only that, but a reference to, and then I pass that on. Or I actually use these two in this function 1, but in function 2, I pass in the reference and then a couple of numbers, and you can see the form changes. But the point is that I actually pass all that along, but I don't have to. I mean, if I define my function to only accept x and y, I just have to pass it x and y. In fact, I could design a, just try to keep it I could do that, for example. Okay, make a function like that, but I can't return it. Just remember that. But I could do, I could call it I think I can call it. Let's see. What am I doing wrong? Oh, I might not be able to because I'm not passing it in, so there's no real reference to it. yeah, I mean, yeah, it would have to be passed in the same way that function is passed in, so I can't really do that per se. But I was going to say that it's not necessary though to pass in those pointers and stuff. That's I'll just comment that out. I don't want to go through the because I'd have to basically create a whole new function. I don't want to get into it. But you get the point. I mean, you don't have to pass in these xrefs or you know this integer or these pointers or references. You don't have to pass that to the other function. It could be as simple as this. If it had been passed in to begin with. But that would fuck up my code down below. So I don't want to really do that. I'm almost surprised you can't just pass in the function, without having to declare the form. But I guess that's for the compiler or something. I'm surprised I can't just put function one, and have it treat that like a pointer function, like this. Yeah, it won't let me do that. So I mean, it had to be a form. So then I have to return an integer. Okay, like that. So that's my point. You can pass it in like that. Okay, it does not have to be. It does not have to be set up that way. You know what? Well, hell. Copy this. Put it here. Cut this out. Put it here. But I'm going to call this function 2 creatively enough. Just to tidy up my code, I'm not going to mess with it. Cause, I mean, you get the point. I mean, the point is that you don't have to do stuff with these parameters just because they're passed in. You can totally ignore them if you want. But the point is that, in fact, to really piss other programmers off, you ought to have it accept like 50 parameters and have it only use like 2 or 3 of them, so that they have to type all that shit in. But the point is that that's all this really demonstrates. It's really just about that you can pass stuff in, and I kind of explore down here because again, I was in the point of learning. Let's see, I shouldn't have errors down here unless I forgot to remove something, and I probably did, and I forgot to clean up that function. Okay, yeah, because I knew that was going to happen. That's why I didn't want to mess with it. Okay, gotcha. Alright, I can comment that out, and all should be right as rain, no frickin' errors. Groovy. Okay, now, but like I said, you can pass in, when you're passing in references, to a function, again, you just have to pass in a variable name, and, you don't have to, do anything special. So that's what's nice about having references, because this is where I learned this, actually, is that, if you have a reference declared as input to your function, you just have to pass it a variable name like I do here, because see, I have triple x defined as an integer, so I didn't have to pass it a reference. I just had to pass it a variable and knew to convert it to a reference. Now with pointers, I have my r value pointer up here, it's an integer, but I have to pass it in as a reference. Okay, even though it's just a variable, I'm passing it in as a reference, and this is accepting a pointer input on these functions. So it's actually working with the local pointer to this variable, but this variable is not a pointer. But so you can pass the address in, and it'll convert it just like I say, you know, somewhere in these gobbledygook statements, you know, it's converting it to a local pointer, even though it's not a pointer you're passing into it, but it's converting it to a pointer locally. So it's, you know, it's using that pointer as a reference up in the function, you know. So, but it, you know, this whole function just returns an integer, so it's going to, you know, return that to R value 2. You know, the R value is defined here, and that's an integer, a different integer. So, but at any rate, so that was kind of cool, you know. But you can also pass it a pointer, just like I do here. So, you know, this is an actual pointer, and, you know, I point it to, you know, this function here, you know, this variable. So I'm essentially doing the same damn thing, just going through an intermediary. I'm going through an actual pointer. Whereas here, I'm, you know, modifying, you know, that same type of variable, or that same variable, you know, in this case the same type of variable. I'm modifying it just by passing it as a reference and letting it deal with creating this local pointer up there. But I could have just as easily passed it in as a reference like I did with triple X, and then, you know, that would have worked just fine too. Again, it's kind of a silly way to go about it, but it just shows you that you can if you ever need to. So you can, you know, create a pointer, or you can just pass it in as a reference and it'll create a local pointer in the function. Or just better still, just use references whenever you can, because you should just use references wherever you can. With functions, you shouldn't generally try not to mess with pointers. It's better to mess with, you know, because that's just more headache on the other end. But, you know, there are times you need to, you know, if you're passing in objects or whatever. So anyway, you know, that pretty much you know, covers this little program here. So oh, I don't know if I ever ran it. You know, no, I didn't. It's all the brown on the side, so I want it green, so that means it's saved. So this is the result of the function, you know, for what it's worth. And remember, I said that one value is going to return 20, so okay, there we go. So let me put this up here. Okay, but you can kind of see what's going on, you know, as a result of the program running. So anyway, I'll just press any key to continue, and Bob's your uncle. Okay, so let's look at the next project. That was the function pointer mystery. Now DirectX 12, you know, this is just me screwing around with the basic wizards just to see how unbelievably complicated that shit is with DirectX. You wouldn't believe, I mean, some of these things, you know, this is just the default bare bones, you know, project wizard, you know, for Visual Studio generated DirectX applications. These are hundreds of lines long, spread over like, you know, 8 or 10 different fucking files. So, I mean, just for a simple cube that rotates. So, anyway, I'm going to go ahead and save this as a separate video, so